Hey, you guys, welcome to this episode of Roadside Insiders. I wanted to come to you tonight with a topic that seems to be looming over all of tow technicians and light service technicians that are out there doing wonderful roadside service work for us throughout this nation, practically throughout the world. However, do you ever find yourself where you're a little anxious about maybe going and servicing an EV? I wonder why that is. I work in an industry, and I work in the towing industry, but where I work, I get a lot of feedback. And a lot of the feedback that I've been hearing lately is people are turning down calls because it's an EV. People are not wanting to run that call. They're willing to take the hit and not get paid for it just because it's an EV. And it worries me because I wonder why that is. Well, we live in a fascinating world where we're looking at technology and the evolution of the vehicle as we've known it. And it's important for us to kind of take a deep breath, I think, and realize that it's really not that complicated. We're really our own worst enemy when it comes to this EV technology. We have to take a step back and look at it from a 30,000-foot view and dissect it as far as what are its major differences. I'd be willing to say that there are more similarities to the EV and the internal combustion engine vehicle, than also known as ICE, than there are differences. So in this video, let's actually take a moment and dissect the two and see what are those differences or those similarities. When it comes to an EV is just a car or it's just a truck. It has a body, it has four wheels, it has a propulsion unit, has seat belts, has radios, has a key, all the same things that we've been dealing with for over a century now. So, just because the gasoline powered vehicle has evolved to what it is today, it hasn't stopped us from doing service to these vehicles. We've been able to continue to provide the same services for decades to the same vehicle today. And the EV is no different. And this is how I want to bring it to light. When we look at a gasoline powered vehicle, what do we have? We have a vehicle that has to have a source of fuel, right? And that source of fuel in an ICE vehicle is gasoline. In an EV, that source of fuel is electricity. Both of those items need to have some place to be stored. For a gasoline powered vehicle, we store that gasoline in a gas tank. Pretty simple, right? Well, where do you think I'm going with this? In an EV, we store the electricity in a high voltage battery. That high voltage battery pack that's in the vehicle, we're not going to do anything with. It's a storage tank for the electricity used to provide propulsion to the EV. When it comes to the fuel tank and getting that fuel to the engine, and that brings up another good point. A lot of times, folks unknowingly, they actually misspeak what the actual terminology is. They call it the wrong thing. So in a gasoline powered vehicle, you have a engine. In electric vehicles, what took place of the engine is a motor, an electric motor. So if you're talking about a gasoline powered vehicle, call the power plant an engine. If you're talking about EVs, call that power plant a motor. just so you sound educated and you're informed on the differences. Now, when it comes to getting that gas to the engine, we have fuel lines that run from the tank to the engine. It's no different for an electric vehicle. To get the charge, the high voltage charge from the tank, which is the battery pack, to the electrical motors, we use high voltage wiring to take place of those fuel lines. We already went over the difference between an engine and a motor, so the power plant in a gasoline powered engine, once again, is an engine. The power plant that provides propulsion in an EV is an electric motor. Now, this is where it kind of gets a little bit different because the electric motors can be placed anywhere in the vehicle. There could be an electric motor for each wheel. There could be one electric motor to operate the two front wheels, one electric motor to operate both back wheels. So this is one of the benefits that they found of being able to move to electric technology is they can move these things to better accommodate the vehicle. when it that is the biggest difference when it comes to these vehicles. Now, because we're using electric motors in order to provide propulsion, unlike the gasoline powered engine, we don't need a transmission like we are used to today, where in a gasoline powered vehicle, you have an engine that has a power plant with that lower crankshaft turning. It then transfers that energy that is created from the combustion in the cylinders of the engine, creates the force to turn the drive shaft and turn the transmission, or I should say, turn the transmission, which then spins the drive shaft and transfers that energy out to the wheels. Whether it's through a rear wheel drive where the energy is gone through the drive shaft to the back, or you have a differential that then takes it someplace else. So we don't have a transmission. Now, any of you out there that maybe has some kind of familiarity when it comes to a golf cart, an electric golf cart. An electric car is almost the same as an electric golf cart when it comes to how the transmission works or the propulsion works of the cart. If you were to tow, and this is where I'm getting with this is when it comes to the where I'm going with this is when it comes to the where I'm going with this is the shifter. So, an electric golf cart, if you're familiar with it, or if you're not, you're about to learn. Electric golf carts, if you were to tow an electric golf cart, you could actually burn up the motor in the golf cart. When it comes to EVs, that same principle applies. In an electric golf cart, there's actually a switch, a maintenance switch that is under the seat that you actually have to flip in order to disengage the drive motors from the wheels. That way it rolls freely and you don't run the risk of damaging your electric motors. Now, when it comes to an electric vehicle, there's no switch necessarily to flip. However, what they have done in electric vehicles is they have provided either a car wash mode, you've probably heard it called that, or a tow mode, you may have heard it called that. It's the same principle. By pressing and putting into a certain mode, you're disengaging the vehicle, allowing it to freely spin the wheels without damaging the motors. Now, it doesn't give us a go ahead, so to speak, to be able to just put it in tow mode or car wash mode, lift it with the wheel lift, and everything will be fine. You got to remember, an electric golf cart, when it's being towed or it's being moved, it's being done at low speeds. Kind of like a car wash. Being pulled through a car wash is being pulled through really slow. We can't do that and expect to put it on the back of a wheel lift and allow it to run down the highway at 55 miles an hour without any consequences. So that's why that doesn't work. However, they do provide tow mode or car wash mode for us to be able to put it in this free will, so to speak, so we can load it onto a car carrier deck or to be able to reposition it and move it to be able to load it. That's all it's for. Remember, all drive wheels, and this is an industry standard that carries over to these. All drive wheels should be lifted off the ground, whether that's with dollies. Some electric vehicles can be towed with wheel lift and dollies, but most of them are wanting the electric vehicle to be put on a flatbed or a car carrier. And the reason for that is because if something were to happen, they want to protect the vehicle. Now, Willift and Dolly's, I recently released a video saying that Cadillac has taken some bold moves when it comes to their warranty. Hopefully, these other manufacturers don't follow suit and do that same thing. However, we need to protect ourselves and not allow these vehicles to get damaged in any way and let it fall back on us. Because when it gets to the shop, they're going to say, this is what we found, and then they're going to put it back on you as a potential cause. Maybe you did, maybe you didn't cause it, but you're an easy scapegoat if you don't protect yourself. To prove that point, just this last week, I was at General Motors in Detroit doing a load test on a vehicle that is soon to be released, the 2025 Cadillac Vistic. While I was there, I saw inside one of their maintenance facilities as I was being escorted, and I asked, hey, what's that thing? They actually drive their cars, and they're testing this technology where they pull the car through this machine into the shop and actually does a full scan of the complete car, exterior and undercarriage, and everything that it can visibly scan to see what the condition of that vehicle was before as it comes into their shop. Before they put a hand on it to work on it, it's being scanned, and I was told it can look at the paint. It can tell if there's any scratches or anything that's there. It can also look at the suspension components and see if there's anything that's at fault there. So these dealerships are taking stances to protect themselves, and we need to do the same. So back to the EVs. When it comes to the EVs, we can still tow the vehicle. Granted, some of them come with eye bolts. GM, I would say, has actually taken some forward thinking, and they've reinstituted a lot of T slots underneath the vehicle so we can actually attach directly to the vehicle itself. However, a lot of EVs out there are still utilizing eye bolts. If you're if that is a recommended procedure, you need to follow that recommended procedure. But remember, not all eye bolts are used for loading onto car carriers. Some of those eye bolts are simply for transporting the vehicle on ships and cargo containers or whatever to its destination. So make sure that you're following the recommended procedure that is found in the owner's manual. We hope to bring you some of that information going forward in the future. However, if you're going to use an eye bolt, I also recommend using a secondary strap as a catch in case the eye bolt fails. Things to watch for when you're using the eye bolt on any of these vehicles is when you attach to it, it's a left-handed thread eye bolt. When you screw it into the receiver, look and see if your winch is spinning. If your wire rope is spinning, make sure it's not spinning and allowing that eye bolt to come loose. However, regardless, if you have a secondary strap, and this secondary strap can be about 12 foot long, whatever distance it would need to go from your grab hook that's attached to the eye bolt. Don't loop it onto the eye bolt. Attach it directly into the grab hook, running it underneath the vehicle and wrapping a lower control arm, leaving slack in that secondary strap so you're not putting force on the lower control arm. However, if the eye bolt were to fail, this would allow another system to catch the vehicle so it's not careening down your car carrier bed into a parking lot or, heaven forbid, out into a street where it can get someone hurt. You still maintain control of that vehicle. It's better to pay for the repairs of the lower control arm than it is to have a major lawsuit or be tied up in a major lawsuit because someone got killed or injured from that vehicle coming off your deck. Don't be afraid of the eye bolts. Just be cautious of them and take the necessary precautions to protect yourself. Now, if you're going to be using the eye bolt, a lot of times you'll see the eye bolt is offset. With that eye bolt being offset, use a snatch block with a short chain or something to offset your wire rope as it's coming up the deck. That way it pulls straight and it doesn't put any unnecessary force on the eye bolt and pull it in an awkward direction. It'll also help keep the vehicle coming up your flatbed straight rather than pulling to the center where that winch is being spooled from. Now, so we can tow these vehicles. Now, the downside is, as we talked to a moment ago with the tow mode or car wash mode, there's no shift interlock override with these vehicles. So if you do find this vehicle where it can't be put into tow mode or car wash mode, you need to make sure that you have adequate skates to load it. It's going to take using go jacks to put it in position or using the skates and a little bit of extra winching to put it into a position you can load it. However, we are still able to do this. So with that said, make sure that you have adequate number of skates. How many skates should we have? By the way, if any of this is ringing a bell to you, please let me know in the comments section below and share this with your friends. But one of the controversial things that, a lot of tow companies don't want to do is they don't want to spend a lot of money on equipment. However, with the evolution of the technology that we're seeing with these vehicles and all-wheel drives, period, we need to start carrying more than just 2 or 4 skates on our truck. We need 1 skate for each non-rolling wheel. So every drive wheel that is on the ground, we've got to be able to lift that vehicle onto that skate and let it slide with the skate so we're not causing any damage to the drivetrain. Now, if we have 4 wheels, we have 4 skates occupied. The other 2 skates, so I'm saying a minimum of 6 skates on your truck. The other 2 skates, you can actually use those as ramps to help you get over that initial lip at the end of your car carrier deck and get it up onto the bed of your truck. It'll make your life so much simpler. You'll work more efficiently and you'll look actually prepared to do the job and impress your customer. However, if you don't need the two extra skates, and say that vehicle is sliding to the side a little bit and is starting to get close to your bed rails, you're able to use that skate by flipping it with the bottom side of the skate against your bed rails and put it between the tire and your bed rails to keep it off that bed rail. Because any contact that rubber makes with any surface is going to add resistance. And it's also going to run the risk of you damaging the wheels on that vehicle. So you can actually flip that skate onto its side and use it as a barrier between your side rail and that wheel to keep from damaging any of the wheels. A lot of these wheels may be chrome or some kind of aluminum alloy or alloy that can be easily scratched, and you don't want to be blamed for any of that as well. Now, once we got it up onto the truck, we got to be able to get it back down. Having the two extra skates gives you an opportunity to be able to maybe get it off your bed a little bit easier, because once it gets to the ground, it's going to meet resistance again. And you can use those extra two skates to help break that resistance even further when it comes off your deck. Now, we talked about towing. We can tow these vehicles. Tire service. A lot of them come with run flats, or they may come with an inflator kit. So if you get a flat, odds are you're going to be towing it anyways. Just make sure that you're paying attention to the amount of clearance that you have with a flat tire, so you're not chancing making contact with the vehicle onto your truck. We can also do key recognitions. If a vehicle key battery or key card is not being recognized, in the owner's manual, there's a recognition procedure that you can locate, and you can actually get that vehicle going for the member and or the customer, and you can tell them that this is what I found. You just need a new battery, and they can go get their little watch battery and throw it into their remote, or they can take it to the dealer and they can have them take care of it there. We can also do lockouts. Now, some vehicles, because of their price, because of the configuration of the door jambs and so forth, it may not be very wise to do a lockout on it, but most of them we still can. And I know for a fact that not a lot of us are using the in-the-door tools. We're accustomed to using the air wedge along with the long reach tool. And a lot of these vehicles, because of the design that they have for releasing the door, a long reach tool and an air wedge is the correct method. Now, in the electric vehicle, there's a lot of times there's an electric actuator that actually opens the door. However, because of the fact that you have to be able to get out of the vehicle in the case of an emergency, these vehicles are being mandated to have a mechanical release. Now, the trick is finding where that mechanical release is. I can tell you, like, for instance, this last vehicle that I just went and did a load test on, that vehicle has a mechanical release that lifts straight up, similar to that of Tesla's. Right there on the door handle, inside, just behind the window switches, there is a vertical paddle that lifts up to open the door and is mechanically operated. I was able to get an air wedge in there, reach in with the long reach tool, and be able to open that door by lifting that mechanical release. Just be mindful that you're doing it from the passenger side. And you'll say, well, I always go to the driver's side. Please stop going to the driver's side. because you're opening yourself up once again to damages, to complaints. If you go to the passenger side, they're less likely to hear that from when you wedge the door too much, and now they have a whizzing of air going past their ear on the driver's side. They're less likely to hear it from the other side. Plus, if anything were to happen and you were to cause the vehicle to cause damage to the door, however the door is still shut, they're still able to operate the vehicle. But if you do it to the driver's door, they're not going to be able to. So you start using that passenger side and be mindful of the uh, be mindful of the paint. Be mindful of plastic, especially in the cold, like we're having now, and be mindful of the weather stripping. Make sure you're not cutting or ripping the weather stripping. So we talked about tow, we talked about lockout, we talked about tires. Some when it comes to fuel delivery, yes, we can't do that. There's some folks that are out there that are doing uh, mobile charge, getting them kind of like a fuel delivery where they're delivering just enough to be able to get them to a charging station. That you're probably not going to want to do that because of the time that it takes to charge it up enough to get it to a charging station. So we're back to a tow again. Now, here's the final piece that I want to make sure to spend some time talking about. We can jumpstart these cars. Most, and I put emphasis on that, most EVs come with a 12-volt battery. It's located somewhere under the hood. It's located in the trunk. Somewhere in that vehicle is a low voltage 12-volt battery, just like we've been using for decades. So we can jumpstart this vehicle. Now, jumpstart on an electric vehicle is no different than that of a gasoline-powered vehicle. We're providing it enough charge to be able to engage that power plant. So, in a gasoline combustion vehicle, when we provide it a charge, we give it enough charge to be able to turn the vehicle over to start its own production of energy, where it's pulling gas from the tank, combusting it in the engine, the alternator's turning at this point, providing juice going back into the battery. And a lot of times, if the battery can keep up, that vehicle will maintain its operation. However, when it comes to an EV, what's different about it is the 12-volt battery is its starting point. And that 12-volt battery needs to provide enough charge to be able to activate that power plant. And the way that it does it, if you're familiar with relays, is very similar to a relay. A relay operates a low voltage circuit or low energy to control a higher energy circuit. So what we're doing is we're using a low voltage circuit to then, like a relay, if you have a connection that is broken, is an open circuit, right? Well, when we engage the low voltage side, what happens is it produces a charge that then makes those contacts for the high voltage side to activate, closing that circuit and allowing the energy from the high voltage battery to go to the electric motors, the power plants. So we're just using low voltage, which is the only side of the vehicle that we're trained to work with and are safe to work with, to create enough energy to close that circuit to now draw energy from the high voltage battery. Now, with that said, the high voltage battery has to have enough charge to be able to get it to its destination. That destination should be a shop. so they can get that low voltage battery replaced or tested, and whatever recommended service is needed. But we're still jump starting the car. We're still able to do that. However, when it comes to where to hook up, you're not always going to go directly to the battery in these vehicles because of where they've positioned the the battery, where they've located the battery. It may make more sense to use the jump posts that are provided and that they recommend using. So know where the recommended jump posts are. Where do you think you would normally find them? Usually, because people are accustomed to going under the hood, you'll find them somewhere under the hood or in an electric vehicle. Now they're commonly being called frunks because they have storage space in the front. So they'll commonly have a removable plastic panel that you can take off, and it's easy to remove, but it's going to be labeled with the positive sign, and in there will be your positive connection point. And then your ground is either going to be a ground lug that's clearly visible and labeled, or it's going to be some kind of unpainted, uninsulated, clean metal bolt or lug. Commonly, you can find one on a strut tower bolt to be able to use for ground. But make sure it's clean, unpainted, and uninsulated metal contact that you're using. And it's not a bolt that's holding on anything like a computer module or anything like that. It doesn't make any sense anyways because that bolt is holding on plastic. So you're less likely to get a good contact there anyways. So we can jumpstart these cars, we can tow these cars, we can do lockouts on them. We're likely going to do a tow for a tire. It's everything that we've been doing for decades. There's really no reason under the moon that I can think of to be afraid of these vehicles. Now, you might be still a little bit on the fence because you're thinking, well, if it has a dead battery, it's fully electric. How do I get into the hood? How do I get uh, in through the door? Well, they thought of that. A good example would be like Tesla, where the tow hook is. If you remove the cover for the eye bolt receiver in the front bumper, a lot of times you will find a couple of wires there that might be used to provide a power and a ground that you can connect your jump pack to that will energize the car and wake it up to where now you can make entry into the car. Or they'll have some kind of mechanical release, maybe in the fender wells or something that you pull that will release the trunk or release the hood. The one that I was just working on Monday, it actually has a mechanical key, and they were smart enough to put the mechanical key in the back, where even though the battery's under the hood on the driver's side, they put the jump post in the back where you can use a mechanical key to open it manually and have access to jump ports or jump posts that are behind removable covers in the underneath the cargo floor. So there's you don't have to provide power to it before you even get it open. You can just open the rear hatch and gain access to the jump post right there, and then provide power to it. And then you can get into the car. You can open the hood using a mechanical hood release, as we're normally operating with on the driver's kick panel. So when it comes to these electric vehicles, there's really nothing to be afraid of. Probably our biggest anxiety comes from the lack of knowledge. And what I would say is lack of familiarity. What I would say is familiarize yourself with the operations of these vehicles by taking the time to look up the the recommended jump points, looking to see if they have a eye bolt or if there's another connection. Just know that, you know, a lot of times with these vehicles, when it comes to towing, you're going to end up having to escape these vehicles if you can't get into tow mode or car wash mode. And for that functionality to work, you have to have a good charge on the 12-volt system. At no point are you in danger of high voltage shock because we're staying away from any of the high voltage components, which are clearly labeled and are brightly colored wires run throughout the vehicle. Plus, you got to think they've made these vehicles safe for their buyer. They made them with their buyer in mind, someone that doesn't even have the level of car knowledge that you have. So they don't want to put these wires unlabeled and nonchalantly in throughout this vehicle to where their buyer can get injured and open themselves up to a lawsuit. So they have run these wires where they're less likely to be made contact with by anything on the ground, by anyone reaching underneath, and inadvertently by opening the hood and reaching under the hood inadvertently. It is clearly labeled and clearly visible that, okay, that looks different. I need to stay away from it. Plus, on them, they have all the labeling that says warning. So the fear of getting shocked or anything like that is very, you shouldn't even have any fear of that. But that's all I have for you for this time. I hope you found this helpful. And until next time, stay safe out there.